All right, guys. Once again, let me know when you see and hear me so I've got an idea that I can get going. And we are looking tonight at systems of equations. That's what we're looking at tonight. So once I see at least somebody in the chat, we can hopefully go ahead and get started. Always nervous that I'm doing this all by myself. Be very scary. And I'll still do it, actually, if I'm all by myself, but I don't think I will be. Okay, well, we got at least one. Sam's here, so we're good. All right, so we're going to take a look at systems of equations tonight. And again, just similarly to what I did with graphing, I initially just want to make sure we have a decent amount of background knowledge here, okay? First things first, what does a system of equations look like? Well, it'll be two or more equations with usually two or more variables involved. So like an example would be 3x plus 2y equals 7 and x plus 3y equals 7. Okay, that would be an example of a system of equations, okay? What you're trying to do in a system of equations is basically find the x and y value that work for both equations, okay? So for example, for that first equation, x equals 5, y equals -4, makes that equation true. If I plugged a 5 in for x, I'd get 15. A -4 in for y, I'd get -8. 15 and -8 makes 7, right? For the second equation, x equals 7, y equals 0 works. And yet, if you were to kind of switch those and plug that blue solution into the top equation and that red solution into the bottom equation, it wouldn't work. Okay, you would get, there would be a wrong answer for that one. Okay, but if you were to plug in x equals 1, y equals 2 into both of those equations, it would work, right? If we plug it in the first one, we get 3 plus 4 is 7. If we plug it in the bottom one, we get 1 plus 6 is 7. Okay, so that one works for both. Okay, so basically what you're trying to do when you solve a system of equations is do that. You're trying to find the solution that makes both equations true. Okay, so how do we do that? Well, we have three basic methods: graphing, substitution, and elimination. Okay, we'll look at those in order, the basic idea and the basic concept behind each, and we'll just see what we got. Okay, so graphing is actually theoretically the simplest concept. Okay, basically what we're going to do is this: we'll graph this top one in red, and we'll graph this bottom one in blue. And here's the idea. Remember, when you're graphing, what you're doing is you're just literally listing all the different possible solutions, like on a graph. So the red line will represent all the solutions to the top equation. The blue one will represent all the solutions to the bottom equation. And figuring out where they intersect, where they cross on the graph, well, that must be the place where it's a solution to both. And that's kind of our end goal. How you do the graphing, guys, that's entirely up to you, and it depends on the equation that you have. I'm not going to tell you explicitly how to graph, okay, but we did just look at graphing again a couple days ago, okay? So really quickly, I'm going to actually do these by making a table, okay? So for the red one, make an XY table, and I'm just going to start putting in values that make it true. So I get 6 and 0 works, 0 and 3 works, 4 and 1 works. Okay, those are all different solutions that work for that first equation when I plug them in for x and y. Okay, and again, I'm not going to go into a ton of detail on the graphing, but those solutions all work. And let's see, where's my 4, 1? There's my 4, 1. Okay, so I'm going to connect those with a line. Looks like there's probably another one somewhere right about there as well. Okay, so I'll connect those with a line. And hopefully I don't need to go any further than that, but if I do, I can. Okay, so now I'll do the same thing for that blue equation. I'll make a little table and some solutions that make it true are 0 and 8 makes it true. -4 and 0 also works for that one. And there's a couple others. I guess I should probably get at least one more. Let's go -2 and 4 would make that true. Okay, so let's plot those. There's 0, 8. -4 zeros right here. Keep doing that. I don't want to keep doing that. And -2, 4 is right here. Okay, so it looks like on at least one of these, I'm gonna have to keep going a little bit. Okay. So let me try going a little bit further on my red one. If you look at that red one, I'm going to just keep the line going. And if I had an actual straight edge, this would probably be easier. But I see a little bit of a slope here, right? Up 1 over 2, up 1 over 2, up 1 over 2. So I'll just go up 1 over 2 again, extend my line, and it looks like they intersect right there, which was that -2, 4 point. So x equals -2 and y equals 4. And I could physically plug both of those back in if I kind of wanted to double confirm that they did work for both, and it does. Okay. We actually have another graphing one next, and I just wanted to illustrate that for this one I'm not going to make a table. Okay. Some people seem to think that just because we're solving a system with graphing means I need you to make a table. No, I don't need you to make a table. You are literally just graphing both lines and telling me where the equation is true. Okay, so again, I'll do the top one in red, do the bottom one in blue. The top one, that's slope-intercept form. My y-intercept is -2, and my slope is 3, so that means I'm going to go up 3 over 1, up 3 over 1, and I'm going to do that a bunch. Okay, I'll do it all the way through. Connect those with a line. You know what? I've drawn worse lines there. Okay, same thing for the one in blue. My y-intercept is 7. And my slope is -3/2. So I'm going to go down 3 and right 2. And look, looks like they're going to intersect right there. So I'm going to stop once I found where they intersect. Okay, it's that point right there. That has coordinates of x equals 2 and y equals 4. And again, you could try plugging that in for x and y and make sure it actually made the equation true, and it definitely does. Okay. Graphing is just typically a little bit of a harder one for me to explain because really it's just graph both lines on the same graph and see where they cross. Okay, biggest advice there is make sure you graph your lines carefully, and once you find a consistent slope, extend that line as far as you need to until you see where they cross. Okay, now come the two algebraic methods. Okay, the first one is substitution. Okay, substitution basically involves basically you're trying to get an equation to look like x equals and some stuff with y on the other side. I'm just going to write y stuff, okay, or y equals and then x and some other stuff. Okay, that's kind of what I want to get to look like. I just want x equals or y equals. Okay, so like in this one, I could totally, if I wanted to, I could solve for x in that first one. But why would I want to? I already have y by itself in this one, so I don't actually have to do any physical math work there. Okay, so what I'm going to do is I'm going to take the fact that I know that y and 4x minus 1 are equal from my second equation, and I'm going to plop that in to my first one. Okay, so I'm writing -x minus 7, and here's where I take out the y. Okay, so I'm taking out the y. Make a little red circle around here instead because I'm about to do this in red. 4x minus 1 equals -22. Okay, so all I'm really doing is taking the y physically out of the equation in that top one, and I'm putting in 4x minus 1 because that's what I just found out it's equal to for this particular problem. Okay, after this point, guys, it's really just a straight linear equation. So like I'll distribute, I'll combine like terms, but really you're just solving from here. Like this is not really part of the substitution process. You have already done the substitution part. Okay, so now you're just doing things like I'm going to subtract 7 from both sides. I'm going to get x by itself, right? I'm going to combine those like terms. I get negative 29x equals negative 29. Divide by negative 29. I get x equals 1. Woohoo. Okay. As always, you need to know both x and y. You need to know the x and y that make the equation true, okay? So once I find x, I can plug it literally in for any of those x's in my original problem, okay? I'm going to use the y equals 4x minus 1 equation, okay? So I'm using y equals 4x minus 1, but I'm substituting x in there, and I get y equals 3. So I get x equals 1 and y equals 3. Okay? Now, all substitution problems are not created equal. Okay, so this one is another substitution problem, but the major difference is over here, I had y all by itself already. Okay, so there was no work for me to actually really do. Here, I need to get one of these 4 variables by itself on one side of the equation. It doesn't really matter which one I choose. I can do whatever I want, but for sure the easy one here is the x in the bottom equation. So I'm going to get that by itself. I'm going to do that simply by adding 4y to both sides of that equation. Okay, and I get x equals 4 plus 4y. Again, once I've used that bottom equation, now I'm going to do the substitution in the other equation. Okay, so I get 3 instead of x. This is where I'm making my sub. 4 plus 4y. Okay, so I'm substituting out a different variable this time, but the process is exactly the same. Okay, and now all I'm doing, again, once you've done this, you haven't finished, you're not done, but you've really done the substitution part. Everything else after this is really just solving for y, changing y to that number, and solving for x. Like you're just kind of going through and doing both those things. Okay, I will finish that up. We get 12 plus 12y plus 8y equals negative 8. I'm going to simultaneously subtract 12 and combine my like terms. Looks like I get 20y equals negative 20. Divide by 20, and I get y equals negative 1. Plug that back in literally anywhere for any one of those y's. You just need to make sure there's an x in there too. So I'm going to go up to that x equals 4 plus 4y piece. Okay, I'm going to change my y to a negative 1. Oops, small mistake. Try again. 4 times negative 1. It looks like if I do math there, that's 0. So it looks like I get 0 and negative 1. And again, if you were to plug those into both, like if you plug it in the top one, you get 0 plus negative 8 when you plug it in. Well, that works. On the bottom one, you get 0 plus 4. Okay, that works. Works for both equations. Okay. The last method we're going to look at is elimination. Now, we'll look at the 3 variable system after this too. But this is the last actual method we need to look at. Okay, for that 3 variable system, we're actually going to end up using one of these methods. For elimination, the whole idea is to get your equations to have opposites on one of your variables. So as an example, I might want a negative 10x and a positive 10x in my equations. I don't care what y is. I don't care what the number is over on the other side. I don't care about anything else. But getting this situation is kind of what we're looking for. okay? And if I get that, then, oops, sorry. If I get that, then I'm basically going to add those equations together to get the variables to cancel out to 0, to go away, okay? So it doesn't matter which variable you do it on. Sometimes it's easier, sometimes it's harder on one of them. I'm going to do my x's this time because 3 and 2 look smaller, so why not? You can multiply these equations by whatever number you want, as long as you multiply everything in the equation by something, okay? So I'm going to multiply this top one by -3, and I'm going to multiply this bottom one by just +2. Almost wrote -2, just +2. Because what I'm trying to do is I'm trying to get a -6 and a 6 on my x's. So sure enough, I do that, I get -6x minus 24y equals +66. Distribute my 2, kind of same deal. I get 6x plus 20y equals -50. Okay, I will add these together now. Okay, that's the big thing. I don't want you to think that -6 and 6 are just, yes, they are going to cancel out, but I want you to understand what we're doing there. What we're doing is we're adding those equations together. That's what we're doing. All right, and when we add them together, -6 plus 6 ends up being 0. That's the reason it goes away. Okay, so then when we do -24y plus 20y, we get -4y, and we get +16 over here on the other side. Okay, divide by -4, and we get y equals -4. Cool. Once we have y equals -4, again, same as substitution. Go back and plug it in somewhere. Okay, this is the part that sometimes is a little bit different because we don't have a variable by itself, right? So I'll use that top one. 2 instead of 2x plus 8 times, there's my -4, plugging it in for y, equals -22. Okay, now all I'm doing at this point, again, is really just simplifying and solving. And it looks like x equals 5. And again, we could do a quick double check. If I go to that top one, 2 times 5 is 10. 8 times -4 is -32. 10 and -32, yep, that makes -22. On the bottom, I would get 15 minus 40. 15 minus 40 is -25. Yep, it works for both. Okay. This method ends up being now the one that we're going to use on our 3 variable system. Okay. Guys, 3 variable systems are tricky, and they're tricky just because there's a lot of moving pieces. Basically, what you're trying to do, okay, and if you're following along, this is not something you need to write down necessarily, but just take to heart. We basically have 3 equations and 3 total variables, right? All we're trying to do is turn it into this. That's all we're trying to do, okay? We're trying to get this basically down to 2 equations with only 2 variables. That's all we're trying to do, right? Because we know we can solve one of those, okay? So here, Dara asked a good question to kind of start us off before we even get going, okay? And it's, how do you know which variable to get rid of and what's going to be the most efficient? You can make educated guesses, okay? Like, take a second and think to yourself. I think the best question to ask yourself here is not which one is best, but which one's a bad idea. Which of these 3 variables is a bad idea? You don't need to type anything. You don't need to do anything. Just think about it for a second. Which variable would be a bad idea? Y's. Y's are a bad idea in this case. Okay, and the reason is, well, there's a 5, a 4, and a 3. Those are bigger numbers than 216 on my x's, and bigger numbers than 125. Okay. Now look, if you go by size of numbers, z's technically have the smallest size, right? 1, 2, and 5 is slightly smaller than 1, 2, and 6. But looking at this one for me, the x's look like they're going to get along pretty nicely because 2 and 6 go really nicely together. But I don't think you could go really wrong with either x's or z's. Z's might be a little better because there's a negative in there, but there's also a negative 5. 5's a prime number. I don't know. I'm going to go x's. Okay, I'm going to eliminate x's. So we're going to, and basically the whole process is this. You're using elimination, okay, but you need to do it twice. Okay, so you pick two equations, eliminate a variable. Okay, so I'm picking my top two. Okay, and forgive me, I've got limited room here, so I'm going to have to be a little skimpy on the notation. Okay, I'll do the best I can to verbally explain what I'm doing. Okay, so basically I'm taking these top two equations right here. Okay, and I'm going to try to eliminate x's. Okay, to do that, I'm going to multiply the second one by negative 2. Okay, so I get negative 2x minus 8y minus French toast minus 4z equals 30. Okay, and I'm going to pair it up again with that top one. I guess I'll do that one in blue maybe. I got enough colors to work with here, so this might work out okay. And I'm just going to re-pair it up with that top one, like copied perfectly here. Okay. Okay. I'm trying to be really careful because this is the one you don't want to make mistakes on. Okay. Add these together, and I guess I'll put that result in black. I get negative 13y minus 3z equals 48. Here's hoping I did it right, but I'm trying to be careful. Okay, so that was one elimination. Okay, so that's just like that's the work you do in a normal elimination problem to really just get kind of pretty much the first variable. The problem is now we got to do that again. Okay, we got to eliminate another variable. So I'm going to try to eliminate x's again. Okay, but I need to pick a different combo. I'm going to go with the first one and the third one because I know 2 goes nicely into 6. Okay, so I'm going to multiply that first one by negative 3, and I'll stick that result in green over here. So I get negative 6x plus 15y minus 3z equals negative 54. Okay. What colors do I have left? Oh, I got yellow left. Okay. And then I'm going to take this last one in yellow. Okay. And I'm going to leave it exactly as it is. Okay. So 6x plus 3y minus 5z equals 24. Add them together, and I get 18y minus 8z equals negative 30. Okay. Oops. You know what? I wanted to put that in black. I'm a little picky, so I'm going to do that actually. Take me 2 seconds to redo. Cool. Okay. So now, basically, all I'm going to do is I'm going to try I'm going to try to get these to all kind of match up now somewhere, anywhere. It doesn't really matter where. I'm going to basically do the elimination thing again. Okay, so I'll rewrite those equations in black up here. Looks like I might have barely enough room to handle this. Okay. Hopefully my copying skills went pretty well. Okay. Now, you guys would normally not have to copy. You could probably just kind of write like right down there. Your next equation and keep working down the paper. I don't have room down the paper. I'm working on an iPad. Okay. So I'm going to get my z's to cancel out this time. And so I'll just multiply top one by 8. And I'll multiply bottom one here by negative 3 because I want those opposites there. Okay. So guys, I mean, like, even I'm going to double check math on my calculator here. Is this math I could do in my head? Yes, theoretically anyway. Okay. Is this math I want to do in my head? Honestly, no. Right? Like, this is where issues in these problems go awry. This is where things go wrong. Okay. So I am checking a lot of the math, not all of it, but a lot of the math I do, I'm checking on a calculator. Now I'm going to run out of room there. So I'm actually going to go down here. Sorry about that. Hard working out one of these completely on an iPad. Yeah, guys, 48 times 8. Again, this is something I've got plenty of tricks to do in my head. I could do it in my head. I just typed it into my iPhone calculator. Totally did. Okay, because I think it's really important that I get these numbers right the first time, because otherwise I'm just going to be stuck going back and checking everything and making sure I didn't do anything silly wrong, or that it wasn't a copying error or something like that. Like, this can get really tricky. So you want to make sure that all of your multiplication is done right. Heck, I want to make sure all of this addition is done right. I really do. Okay, that I'll probably do at least a little more in my head, because I'm feeling not too bad about it. Okay, but like even 384 plus 90, you should be able to do that in your head. But like, there's nothing wrong with saying, okay, I'm gonna do that. Okay, when I divide by negative 158 here, I get 3. Okay. Once you get the first variable, guys, you don't have to go back and like redo everything completely. All you got to do is go back to, see those equations we wrote in black that have y and z in them? Just go in and plug into one of them. Okay, I'm going to actually plug into the one right where I made that eraser mark. Right down here is where I'm going to be going, okay? I'm going to plug in down here for y. So I'm doing 18 times 3 minus 8z equals negative 30. Okay, go ahead, buddy. Go ahead, buddy. It's okay. All right, multiplying, I get negative 54 minus 8z equals negative 30. I'm going to pretend I had a little more room for my math down there, and it looks like I get z equals negative 3. Okay? And then to figure out the last one, all you've really got to do is plug back into one of the originals. So I go back up into one of my originals. Okay, so one of those ones that was the original problem. So I'll just do that x plus 4y1. Okay, x plus 4 times 3 plus 2 times negative 3 equals negative 15. Oh, that y should have been negative 3. Oh, that's what everybody's telling me. See, I'm telling you guys, this is where the things go wrong. On the plus side, I did it right over on the right-hand side. My brain was telling me that was right. Thank you guys for correcting me on that one. Whew. My brain was doing it right, but I wasn't realizing that I wasn't writing the negative down. My fault. Totally my fault. Okay. I was definitely going to screw this up over here, though. So that should be negative 3. Okay. Back on track. Sorry about that. Okay. Here we go. So we should get x minus 12 minus 6 equals negative 15. And we do some math, and it looks like x equals positive 3. Sorry about that. It looks like we should get 3, negative 3, and negative 3. Holy cow. Sorry. That was a lot of work to fit on an iPad. Okay. The short of it for the 3x3s is just really make sure that you are being careful with your work. Even I did. I was doing work on a calculator, and I just forgot to write a negative. Luckily, my brain was doing it right over here, or that could have been a little bit of a problem too. So eliminate, then you're down to 2. Okay, big thing is make sure you're eliminating the same variable twice. Okay, and make sure you're keeping track of the multiplication and stuff you're doing, because guys, if you mess this up, okay, especially exam-wise, I wouldn't take too much time on it. Okay, I would get as far as you can and be like, okay, I'm going to come back. But then if you got time left over at the end, if you don't have notes about what you multiplied and what you didn't, that's going to be a problem. Okay, so that's it. Hope this was helpful. If you're watching it later, again, if you got any questions, let me know. Seems like it went pretty well. And we've got exponents on the docket tomorrow. Okay? Good luck studying for exams. Have a good rest of your night.